Let us study a new topic, that is anomalous behavior of water. Anomalous, its meaning a special or a remarkable or a unique property showing by water. So at first, with the help of a simple example, I will explain what is anomalous behavior of water. Now I am taking water which is having the temperature 0 degrees Celsius. So we can say that ice plus water or just ice turns to water. That water I taken here. Now that is having 0 degrees Celsius. Now I am heating it. So we can find that as and when we start heating it from 0 degrees Celsius to 4 degrees Celsius, as and when water getting heated, you can find that the water starts to contract. Contract, its meaning the size of the water reduces. At the same time, its density increases. Density means mass upon volume. So here what is happening, when we start heating, 0 degree Celsius temperature is there at that water. From 0 degree Celsius to 4 degree Celsius, when temperature rises, you can find that water, the size of the water, volume of the water reduces. At the same time, its density increases, weight increases. Now, again from 4 degrees Celsius to 100 degrees Celsius. That means we keep on heating it. So when the temperature increases from 4 degree to 100 degrees Celsius, you can find that water expands. That means its volume increases. At the same time, its density decreases. So here water is having such a special character is there. What is that? From when we heat it from 0 degrees Celsius to 4 degrees Celsius, the size of the water reduces. That means the water contracts. At the same time, its weight, that is density, increases. When we continuously heating from 4 degrees Celsius to 100 degrees Celsius, water expands. At the same time, its density decreases. Now, in case of other substances, when we heat from 0 degrees Celsius to any temperature, you can find that their volume increases. We can say that they expand. Other substances, this is only the special character showing by the water, but if we are heating any other substance, we can find that even if from 0 degrees Celsius or any higher temperature, if we are heating it. So 0 onwards, just example I written, if you are heating from any temperature, we can say as and when we heat, it starts to expand. Its size starts to become more. But here in case of water, if we heat from 0 degrees Celsius till 4 degrees Celsius, it shows a remarkable property. That is, it contracts till 4 degrees Celsius. Afterwards, again if we are heating it, its size increases. We can say that water expands. At the same time, as and when its volume increases, its density decreases. Now, just opposite. That is, if we are cooling, here now water is having 100 degrees Celsius temperature. As and when we are cooling it till 4 degrees Celsius, that means we are cooling now. Here we are heating it. Cooling, we can show this sign also, minus, then heat. So we can see that till 4 degrees Celsius, it means water contracts. After that, from 4 degree to 0 degree Celsius, when we cool it, you can find that water expands instead of contracting. Normally, any object, now here 0 degree onwards, if we are heating it, you can find that other objects, other substances, they start to expand. Again, from any temperature, if we are cooling it. Now again I am showing that an object, now its temperature is shown here 100 degrees Celsius. Now I am cooling it. That means the temperature removes. So you can find that any temperature we are bringing. So you can find that such substances, any substance, those substances contract. Other than water, any substance, when you heat it, it expands. When you cool it, it contract. But water has such a remarkable property, 0 to 4 degree or 4 degree to 0 degree. Remaining time, that means above 4 degrees Celsius, like other substances, it expands. Again 100 degree to 4 degrees Celsius, if we are cooling the water, it contracts. But it shows the remarkable property from 0 degree Celsius to 4 degree Celsius and from 4 degree Celsius to 0 degree Celsius. Here when we are heating from 0 degree Celsius to 4 degree Celsius, we are supplying heat here. You can find that here water contracts. Here now when we are cooling water from 4 degree Celsius to 0 degree Celsius, instead of contracting, water expands. Such a remarkable property of water is known as anomalous behavior of water. Anomalous behavior of water we will learn now with the help of a graph. That graph is showing volume as well as its temperature. This is the y-axis, this is the x-axis. Here now 0 degree Celsius, that means here we are showing the temperature. That is showing in degree Celsius. Here we are showing volume of the water. Volume of the water here. Here now we have taken 1 liter of water, or we can say 1 kilogram of water. Now 1 kilogram means 1000 gram. Now how it is? Its volume is increasing, that I will show you. Here now 1000.05. Now here 10. 1000 is there here. Then 15, 20, 25, 30, 30, 35, 40, 45, 50. Now here everywhere 1000. Point. Everywhere 1000 is there. Now here this point here we can say that 0, then here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means all in degree Celsius. 0 degree Celsius, 1 degree Celsius, 2 degree Celsius, 3 degree Celsius, like that way in degree Celsius. Here temperature shown. Here now mass in kilogram. So 1 kilogram, everywhere 1 kilogram is there, 1000 gram. Then afterwards, here 1000.00. Here 1000.05, then 0.10, 0.15, like that way it is increasing. At 0 degree Celsius, the volume of the water is high. Because of that, that volume I am showing like that way. From this position I am showing. At 0 degree Celsius, volume of the water is reached up to here. Now we are heating it. From 0 degree to 4 degree Celsius we are heating it. At 4 degree Celsius, at 0 degree Celsius, its volume is high. Because of that I put here, just imagining like I put the point here. Now afterwards we people start heating it. As a result of it, its volume keep on decreasing. Finally up to 4 degree Celsius, its temperature keep on increasing. We can say that 0 degree to 4 degree Celsius we are heating it. Here means a heating process we are doing it. As and when we heat, this mass is, this is the volume of the water we are shown. So we can say that here in centimeter cube it is shown. Volume. So here we have taken water, that water its volume keep on increasing. So here we can say that 1 kg water we have taken, now its size keep on increasing. When, if we are cooling it from 100 degree to 4 degree Celsius, it contracts. After that 4 to 0 degree Celsius, if we are cooling it, we can find that the size of the water increases. So this temperature, you can find that water will be in which condition? In the expanding condition. So here now we have considered only 0 degree Celsius. So water is in the expanded condition. Because of that only I put the dot over here. After that we are heating the water from 0 to 4 degree Celsius. So we can find that slow by slow, when we are heating the water, what is happening? Water contracts up to 4 degree Celsius. At 0 degree Celsius, water is in the expanded condition. But once we started to heating from 0 degree Celsius to 4 degree Celsius, we are heating it. But here expansion is not taking place. Here contraction is taking place up to 4 degree Celsius. After that, again if you are heating it, you can find that the water starts to increase its volume. So here now, as and when we heat the water from 0 degree to 4 degree Celsius, we can find that water contracts. But once we start to heat from 4 degree Celsius to 100 degree Celsius, we can find that water starts to expand. So we can find that here this is showing that expansion form, this is showing the contraction form. So this is the graph which is showing the volume as well as temperature of water. So as and when, now here once again if you are seeing, if we are cooling the water from 100 degree Celsius to 4 degree Celsius, if we are cooling it, we can find that water contracts. If we cool the water from 100 degree Celsius to 4 degree Celsius, we can find that water contracts. But once it reaches 4 degrees Celsius, again if we are cooling it, you can find that water contracts. Water expands. When we cool, here now we are doing the cooling process. Arrow I am showing this way. We are doing the cooling process here. So 100 to 4 degrees Celsius, you can find that water contracts. But again we are cooling from 4 degree to 0 degree Celsius. 4 degree to 0 degree Celsius. You can find that water is not contracting, water is expanding. Now, when we heat the water, heating arrow also separate I will show. This arrow will show up to 4 degree. Again now 4 to 0 I will show you. Now here we are heating. We are heating the water from 0 degree to 4 degree Celsius. You can find that here water contracts. Again we are heating from 4 degrees Celsius to 100 degrees Celsius. Arrow this way I am showing you. So 4 to 100 degrees Celsius, you can find that here water expands. So this is the property of water. So when we cool water from 100 to 4 degrees Celsius, water contracts. When we heat water from 4 degree to 100 degrees Celsius, water expands. Now here, when we cool water from 4 degree to 0 degree Celsius, water expands. Now, when we heat water from 0 to 4 degree Celsius, water contracts. Their expansion is not happening. So we can say that this is anomalous property of water. With the help of Hope's apparatus, Hope's, H-O-P-E-S. Hope is the name of the scientist. He made such a apparatus. So here now it is there, with the help of Hope's apparatus, we are going to study anomalous behavior of water. For that, Hope's apparatus we have taken. Now what is Hope's apparatus I will say you. Here you can see that one cylindrical container or cylindrical vessel we can say. Cylindrical vessel. At the middle of this cylindrical vessel, you can find that there is one flat vessel. Flat vessel is there. Both of them are attached with each other. Then downside there is one thermometer. This is one thermometer. Even upside one thermometer. So here now we have to connect two thermometers. Downside one we can write as T1 thermometer. Upside one we can write as T2 thermometer. Now we have to fill the water here. We can say that very cold water we will fill it. Inside full we have to fill the water. If we are filling cold water, that will be very nice. Then result will be cold in the sense 10 degrees Celsius temperature we can take. Suppose if you are taking the water which is having 10 degrees Celsius, then the cooling process will be very fast. If you are taking hot water, then the cooling process will take a long time. So for doing this particular experiment, at least we can take a 10 degrees Celsius coolness is there, such a water. Now here in this middle container or middle vessel, we have to fill salt plus ice pieces. Ice pieces plus salt. So we can say that it is a mixture of. It is a mixture of salt plus ice pieces. So Ice, how much is there? Ice temperature you people are knowing. Its the temperature is 0 degree Celsius. When we add salt in it, then we can say that the temperature of the mixture will be less than 0 degree Celsius. For that only we people are mixing salt along with the ice pieces. So we can say that here now this middle vessel has temperature less than 0 degree Celsius. Now, when we conduct this particular experiment, every 30 seconds we have to check it what is happening to the thermometers, which Celsius it is showing. So here now, here this thermometer shows different readings. Here again this thermometer also showing different readings. Like that. Now, here we had already added water, even we kept the mixture, cooling mixture we can say. Now you can find that after some time, you can find that here now one container I kept, here one tube is connected for removing the water which is forming here. Inside the container, inside this flat vessel, how much water is forming at a room temperature. Now we people are opening and keeping this container. So as a result of it, there will be the formation of water. That for water we can be able to collect in this container. For that here container kept. Now we can find that immediately, that means within few seconds we can say, here you can see that the temperature of the lower thermometer keep on decreasing. Here the temperature decreasing will be very fast we can say compared to here. Here also we can find that temperature is decreasing, but compared to this thermometer, here the temperature is decreasing very fast. So we can say that from here 100 degrees Celsius to 4 degrees Celsius, the reduction of the temperature will be very fast. This is happening in the T1 thermometer. At the same time, in T2 thermometer, temperature reduction. Here now what is there? We kept how much water, degree Celsius water? Only 10 degrees Celsius water. That means as per our wish we can keep. Now for convenience I told you 10 degree. Now 20 degrees Celsius water if you are keeping, then also okay, no problem. But here I am taking 10 degrees. So this 100 degree I am removing. Here I am writing 10 degree to 4 degrees Celsius temperature. That reduction is fast. But at the same time here now 10 degrees Celsius to 4 degrees Celsius. That reduction of temperature will be little slow. Now suppose if you are taking 20 degree, then also no problem, to 4 degrees Celsius temperature. This process will be slow. Here if you are taking 20 degrees Celsius to 4 degrees Celsius temperature lowers, till the time the reaction will be, or the lowering of the temperature will be very quick in the T1 thermometer. Now once the temperature reaches up to 4 degrees Celsius, you can find that here as and when the temperature reaches to 4 degrees Celsius, one more important thing is there, why the temperature of the lower thermometer decreases fast. Its answer, as and when we are keeping this cold mixture at the central part of the cylindrical vessel, in that water is there, this region, how much water is there inside? That is getting cooled. So cooling process will take place inside, or we can say central part of the cylindrical vessel. As and when it gets cooled, that particular time we can say that water starts to contract. Water contracts. Here now this region, at first the middle part we can say water will get cooled. So here middle part I am writing. Middle part of the cylinder. At first what is happening? Middle part of the cylinder is getting cooled. As a result of it, middle part water contracts. Once water contracts, then we can say that its density increases. Its density, its weight increases. As a result of it, the cooled water starts to move downward direction. Cooled water starts to move downward direction. As a result of it, at first this region will get cooled. As a result of it, you can find that the temperature lowering is taking place at the lower region. First middle part, afterwards its density increases, water starts to contract. As a result of it, water starts to move downward direction. But here one problem is there. Till 4 degrees Celsius only its temperature lowers. Afterwards, further cooling is taking place. That means below 4 degrees Celsius. Below 4 degrees Celsius, again water cools. So what will happen to the water? Instead of contracting, water starts to expand. So here we can say that water expands below 4 degrees Celsius. Once the temperature decreases below 4 degrees Celsius, water starts to become big, expands. As a result of it, its density decreases. Its weight decreases. Once its weight decreases, the water particle starts to move upward direction. Here till 4 degrees Celsius, water became cool, but once it became 4 degrees Celsius, we can say that its density will be maximum. So density of the water maximum at 4 degrees Celsius. Density of water is maximum at 4 degrees Celsius. Again it is getting cooled. Instead of contracting, water starts to expand, as well as its density decreases. As a result of it, the cooled water starts to move upward direction. As a result of it, we can find that now before the conversion, or we can say that the temperature was lowering, but it was a slow process. Now you can find that the temperature reaches up to 4 degrees Celsius. Again it reaches to 0 degrees Celsius. So here now starting temperature, now suppose 10 degrees Celsius we kept. Then we can find that now it is continuously cooling and reaching its temperature up to 0 degree Celsius. Once its temperature reaches up to 0 degree Celsius here, then we can find that slow by slow the temperature of the lower thermometer also will show 0 degree Celsius. But 0 degree Celsius, lower part of this container or this thermometer will show after this thermometer shows 0 degree Celsius. When here 4 degree Celsius temperature show, then sometime this temperature remain in the stable condition, same condition, fixed condition we can see. Now till this thermometer shows 0 degree Celsius, till the time the temperature in the lower thermometer will show 4 degree Celsius. Once this part full becomes 0 degree Celsius, then slow by slow you can find that the temperature of the lower thermometer decreases and finally it reaches to 0 degree Celsius. This is the Hobbes apparatus as well as its function. Now we can say that here from this experiment we can understand that 4 degree Celsius is the water which is there, its density will be very high. So we can say that density of the water is maximum at 4 degree Celsius. Now once it reaches to 0 degree Celsius, then we can say that water turns to ice, as well as we can say that water expands. Once water expands, that means the expanding temperature of the water is from 4 degree Celsius to 0 degree Celsius. Here when the water cools from 4 degree Celsius to 0 degree Celsius, instead of contracting, water expands. One more thing we can say, till 4 degrees Celsius water contracts. Any temperature, till we can say till 4 degrees Celsius from higher temperature, any temperature we can see. Higher temperature, water contracts. So here now, at first you see this middle part, water got cold, then that water started to contract. As and when it became cool, it started to contract. As a result of it, its density increased. Then that water started to come down. Then at first here temperature lowering work started. Till 4 degrees Celsius you see here. After that, below 4 degrees Celsius water started to cool. Instead of contracting, water started to expand. As a result of it, its density decreased. Then water started to move upward. Then you could see that this thermometer T2 started to show very quick lowering of the temperature till 0 degrees Celsius. Once its temperature became 0 degrees Celsius, then you could see that this all region very low temperature became 0 degrees temperature became, then it started to move downward. Here everywhere then 0 degrees Celsius temperature became. So once 4 degrees Celsius temperature shown by the lower thermometer, then that 4 degrees Celsius remained some time in the stable condition, in the fixed time. When this thermometer shown 0 degrees Celsius, later this thermometer shown then 0 degree Celsius. This is the functioning of the Hobbs apparatus. Now we will study the Hobbs apparatus explained. That means the Hobbs apparatus shown which experiment. That Hobbs apparatus shown to us anomalous behavior of water. Now that anomalous behavior shown by the Hobbs apparatus, we can be able to explain once again with the help of a graph. This is a time temperature graph. Now here we see two thermometers we used in Hobbs apparatus. Same way here also two thermometers we are showing. Now we can say that the previous experiment which I shown, in that 10 degrees Celsius or 20 degrees Celsius I shown you. But here it is showing 12 degrees Celsius. Any temperature we can begin. So here we are starting with the 12 degrees Celsius. So starting temperature of both the thermometers will be 12 degree. That means when we added water in the cylindrical container of the Hobbs apparatus, upside as well as downside thermometer shown in the starting same temperature. When we mixed the mixture of, or when we added the mixture of salt plus ice pieces, then middle part temperature lowered, afterwards the temperature started to lower downward direction, then upward direction. That you people already noticed. So here now initial time, starting time, the temperature which is showing by the T1 thermometer as well as T2 thermometer same. Afterwards what is happening, as we had studied here till 4 degrees Celsius. This I am showing as 4 degrees Celsius. This all degrees Celsius shown, 0 degrees Celsius, 4 degrees Celsius, 8 degrees Celsius, 12 degrees Celsius. Now, as and when we added the mixture at the central plate or central vessel, we can find that the temperature of the T1 decreases very fast till 4 degrees Celsius we can see. So we can see that the thermometer first, its temperature decreases up to which temperature? Up to 4 degrees Celsius. At the same time, this temperature, this thermometer shows once its temperature reaches up to 4 degrees Celsius. Till the time this thermometer reduced its temperature slowly. After that, once its temperature reached up to 4 degrees Celsius, then the second thermometer start to decrease the temperature in a very fast condition. Afterwards, continue falling its temperature till, we can say, till it is reaching 0 degrees Celsius. So we can say that here up to 4 degrees Celsius the first thermometer shown, then the second thermometer decreasing its temperature continuously till 0 degrees Celsius. This is the top or upper part which thermometer we kept, that is showing here. So starting its temperature reduced slowly, but once the first thermometer shown the temperature 4 degrees Celsius, then second thermometer started to decrease the temperature very quickly, and it is shown the temperature 0 degrees Celsius here. Here 0 degrees Celsius. Then you can find that once this thermometer shown 0 degrees Celsius, then you can find that the first thermometer shown its temperature 0 degrees Celsius. So at first, second thermometer shown the temperature 0 degrees Celsius. Later, the first thermometer shown the temperature 0 degrees Celsius. So this is the graphical representation of the demo which is shown by the, or the experiment which is shown by the Hobbs apparatus. Now we have to study anomalous behavior, how it is helping to the animals or the fishes, then we can say plants which are living in the ponds, lakes which is there in the cold region. Because of anomalous behavior of water, the animals which are living in the cold region, animals which are living in the cold region, we can say their ponds will be there as well as lakes. Such all cold, now even we can say small rivers all will be there. There animals are living, fishes are living, as well as we can say that different types of organisms will be there in the water. During winter season, we can say that there will be ice falling or snowfall region, we can see. As a result of it, upper part of the water is getting very much cooled. As a result of it, upper part of ponds, lakes, you can find that layers of ice forming on the surface of ponds, lakes, etc. Then during winter season, at night we can say that less than 0 degrees Celsius temperature will be there. As a result of it, of course, we can say that on the surface of the water there will be the formation of ice. So we will think how the animals which are living inside that pond, lake survives. But because of anomalous behavior of water, downside water never turns to ice, only the upper part turns to ice. As a result of it, night time animals are able to survive in the ponds as well as lakes. Then daytime will be there. As a result of sunlight, the ice layer which is forming, very thin film like ice layer will form on the surface of the water, that melts. As a result of it, again atmospheric oxygen will react with the or mix with the water which is there in the pond, lake, rivers, etc. As a result of it, necessary oxygen supply will take place. Again night time, same way ice formation will be there on the surface of the water. Now, how it is taking place in detail we will study. Here this is the pond I shown now. In that there will be fishes. Even we can say that there will be plants inside the ponds, lakes and all. Small types of plants will be there. How all these plants are surviving such a cold weather. Here I am saying you, water will be there. This water, downside water never turns to ice. Now here I am showing you a layer of ice is forming. We can say that this is ice formation. Now here I am showing you, this is the side part, muddy part of the lake or river. We can say that this is the border part we can see. So here now this is the pond. Now in that you can see that fishes are there as well as some plants are there. Now what is happening I will say you. During night time, daytime anyhow sunlight will be there. Daytime sunlight is available. Daytime sunlight will be available. Night time we can say that less than 0 degree Celsius temperature will be there. During that particular time atmosphere will be very cool. As I told you, less than 0 degree Celsius temperature will be there. Now, once that cold temperature will enter into this pond. Now here I am showing you the pond. So, less than 0 degree Celsius temperature is there in the atmosphere. That will enter into the pond. As a result of it, we can say that the temperature of the water decreases up to 4 degree Celsius. Once its temperature becomes 4 degree Celsius, we can say that during that particular time maximum density will be there to the water. Water is getting maximum density. As a result of it, water comes down. This water becomes cold when it is reaching 4 degrees Celsius. That particular time water, we can say that means up to 4 degrees Celsius. Now we can say 100 degree to 4 degrees Celsius. Now here normally the temperature will be, we can say that 20 degree, 25 degrees Celsius temperature. That reducing up to 4 degrees Celsius it is becoming. As and when its temperature decreases, we can say that water contracts. Temperature decreases, then water contracts till 4 degrees Celsius. Water contracts till 4 degrees Celsius. Once it gets 4 degrees Celsius, we can say that the water is getting maximum density, then whole water will come downward. As and when its temperature reaches to 4 degrees Celsius, water fully will be downside. Again we can say that here atmosphere will be very cold condition. That particular time the upper part, there will be the formation of ice. Upper part of the water you can see that there will be the formation of ice. One more thing is there, once ice formation will take place, the ice is acting like a bad conductor of heat. Ice is a bad conductor of heat. So we can say that once 4 degrees Celsius reaching, then water comes down. But you can find that atmosphere is still cool and cool. So as a result of it, that coolness passing to the surface of the water. Once this temperature, this particular part reaches 0 degrees Celsius, then there will be the formation of the ice. But this ice formation only will be on the surface of the water. It won't go downward. Why? Because here the water which is having 4 degrees Celsius temperature, that water won't go upward direction. That temperature won't reduce. Why? Because here one support like ice layer is there. Because of the ice layer, downside temperature never reduce. Why? Because this ice layer is acting like a bad conductor of heat. Because of that, no losing of temperature from downside part of the lake or the pond. As a result of it, night time full we can say this downside water full will remain as water only. Because of that, the organisms or the living things which are there inside the ponds, lakes, etc., they survive. They won't get any problem during winter season. Daytime, once daytime become, again sunlight will be there. This ice will melt. Again oxygen particles will enter inside. Night time will become, ice formation will be there. But here this temperature of the water remain constant at 4 degrees Celsius because of the formation of such a protective layer of ice on the surface of the water which is there in the lakes as well as ponds. Thank you.